Hello guys, I am Jim from TOPWELL Spring Development Corporation Limited, and it's a pleasure being with you today in this live show. Today we are going to talk about product development, but in a bit of details. In TOPWELL, we do the whole process of a project development, starting from a mere idea or a concept, and then all the way until the product is manufactured and packed or packaged and ready to be shipped to customers. We mainly work in consumer electronics field, and the amount of variety that we have had or we have seen while developing a new product is really wide. So usually we may receive the customer requirement as just some normal description of how he wants the product to work, how he wants the product to look like, to be used, and then who's going to use it and how is he going to benefit from using this specific product, and what exactly the problem is this product solving for his customers or for the end customer, for the end user. I can see the first guest to our show. It's great to see you in here, and please, if you have any questions, just either send us on the online form in on our website, or just drop us an email message, and one of our customer support team will be with you instantly. So back to the product development cycle. We usually receive the customer requirement, and then we start a series of analysis meetings with the customer in order to understand how exactly does the customer expect his product to be used, who is going to use this product, how is he going to use it, what are the places, the circumstances, what is the situation for this product to be used. And then we move to the next step, is how should this product look like, dimensions, size, arrangement, style, of course color, material, we call it the CFM, color and finish and material, and how does the product feel when in the customer's hands. So usually if the customer comes with a product concept where he already has we call it the industrial design of the product, which means the concept, okay, we start from there and take it to the next step, where we go through the mechanical design of the product. If not, we usually provide the customer with between 3 and 5 different concepts based on his description, based on his expectation on how the product should look like. And then after that, the customer will choose one of these concepts, and then after that we would provide him with another 3 to 5 variations on the concept that he has already chosen. Once this is all done, this also helps us and the customer together to get a deeper estimation, envision on how this product is going to be handled. So either the product is a wearable, where most of the recent products are. It's either a wearable, or it's a desktop, or it's a wall mount, or whatever. There are so many product concepts and mounting concepts for each product. So we usually go through all these possibilities together with the customer until we reach a point where the customer believes that the one we have already settled on is the one that would work perfectly with his concept and with his requirements also. Once this is done and we get the customer's approval on the concept, then we would move to the next stage. On the next stage, we usually diverge. So the mechanical guys, the mechanical design team, will start designing the inner works, the inner parts of the product, and separate the concept into different physical parts by material, by size, by location. So many concepts to work on. And then on at the same time, the hardware guys, who are the electronic engineers, they start to put down the main components, the major ICs, or the major building blocks of the product. With all this in place, the firmware guys also start to lay out the main lines of the firmware. All these activities are taking place in parallel. So the hardware guys would expect the mechanical engineers to send them the outlines of the board, the shapes, and the topographical distribution of the components on top of the board. And let me explain this a bit in a bit more details. Like you see in this, let's say this concept, or this sample PCB. This one, what I mean by topographical distribution, I mean that in a certain areas of the board, it's only allowed with a certain amount of height. There is a limited height on top of the board in here because of the integration with the enclosure. So, and also for any actuators or user interface items, let them be like this. This is a rotary knob. Okay, so of course in the enclosure there will be a specific space where this knob is attached, which means the knob itself has to be placed in this specific location, and then the rest of the board can have the rest of the components, where in some places you cannot exceed the available height because there is a limited height or tolerance distance between the board surface and the above enclosure. So these requirements will be handed over from the mechanical engineers to the electronic engineers, and of course this is a bilateral process, which means sometimes this adds a bit of constraint on the electronic engineer when he goes through component selection, choosing a component. So in this case, if the engineer would find something which will not fit mechanically on the available size of the board or available location of the board, he will just get back to the mechanical engineer and ask him either to increase the clearance above the board, or to recommend another place where this component can be put without breaching the signal integrity requirements. This is from electronics standpoint. And what I mean by this is, sometimes some components has to be put together inside the same board area, in the same vicinity. Otherwise, this may affect the electronic signal transferred from one component to the adjacent other one. In this case, there are always constraints limiting the mechanical placement, limiting the component's performance, limiting the component's placement. Sometimes it's also related to heat. Some components heat up while in use. Even some of them would heat up above the limit that a human being is safe to touch. So in this case, what you see in the computer CPU chip or in the audio amplifiers, these chips heat up and they need to be cooled down via heat sinks, fans, and so on and so on. So this whole process is a design process, which means the designers, not only a single person, the design team has to consider various operating circumstances and situations where they envision the product manufacturing, the product assembly, the product performance, and the product behavior when in the final customer's hands. So let's say I have seen some smart glasses where once you start wearing them, they just start to heat up in some places, either in the front side, causing the front side of the skull to receive some heat from the glasses itself or from the sides. This is a design penalty, let's say, design mistake, okay? Because this was not properly considered. So with these smart glasses, this sort of not very well designed, and this is between quotes, not very well designed glasses, a user cannot keep using the product for, let's say, a few minutes, maximum half an hour or something like this. After that, he is really, the end user is really annoyed by the emitting heat, the heat emitting from the product itself. So this is another aspect of the design team not envisioning all the use cases of their product. Of course, this is easier said than done. Why? Because most of the time, with the very fast pace that we see in all our life aspects, the design process is not far from there. Which means, when we are designing something, there is a time constraint. And within this time constraint, the design team has to consider so many different variables and items and concepts. This means planning for the design process before starting the actual design process itself is more important. Planning is, let's say, not say more important, planning is as important as actually carrying out the design process itself. And here where experience comes in, plus stable and trustable process, design process. While planning for the product, for the product design project, I have seen, we have some new guests in here. Great to see you in here, guys. My pleasure to be your host. And please, if you have any questions or any comments, don't hesitate to drop us a line in our website on the online forum or you can send us email through the website, and one of our support team will be with you instantly. You can also drop us some comments in here in the live show, and of course we will be with you at once. Back to the design process. Most of the time, when you have all the requirements from the customer, we need to be sure that we have not overlooked any possible aspect. So the most common question that comes in the wrong time is when you just start talking about or discussing a project with the designer, and then you just ask him how much. That's a technical foul. Why? Because if the guy wants to give you a realistic and honest cost range, he has to understand your demands first. And understanding doesn't mean just going through each and every single aspect of the product. It means that there are usually weighing factors when included in the project, in the product. These factors are the ones which drives the price. So let's say you are planning to come out with a smart product, which means this product will have an MCU, microcontroller or microprocessor, CPU inside, the amount of memory, if it has an LCD or not, display or not, connectivity, Wi-Fi, Bluetooth, Zigbee, whatever, GSM, which means antenna and modem and things like that. The main items which will drive we call it the BOM cost, the bill of material cost of the board, are the most expensive parts in the product, and including them in the design is a design decision in itself. So let's say if your product only requires interacting with a mobile phone app, would this interaction channel, would this be only Bluetooth or Bluetooth plus Wi-Fi, or should this happen from the device to a server directly, where sometimes there won't be available Wi-Fi signal, so it has to go through the GSM network, which means the device itself has to be able to connect to the internet through GSM network. So which means we will need to include a modem, a GSM modem in the product. And these usually, as I've just mentioned, the CPU type, capacity, speed, size, all these aspects, the memory, size, technology, speed, the user interface, LEDs, LCDs, touch screen. Is there an audio circuit? Audio drivers, amplifiers, we call it signal pressure level, SPL, which means how loud should the volume be. We have also mentioned the connectivity. All these main features for a product are the main driving factors from a hardware standpoint. There is also another aspect, which is how much does the IP cost you. Let's say you are looking for a product which runs Android, or it maybe needs to be running Windows or Linux. So adding these OS, these heavy OS abilities, running abilities to your product means there is a minimum processing power, computing power. There is minimum compute power which needs to exist in your product for it to be able to run this level of these types of sophisticated operating systems. Which means this itself is another driving factor of the cost of the product. Then we move to the third aspect, the enclosure. What sort of enclosure would you require? Okay, plastic, metal, what material, what size? How about the production complexity, the enclosure complexity, the surface finish? Of course, the smaller the product, the more feature rich it is. Of course, this increases the bar of a BOM cost. There is also the assembly cost. Is it easy to assemble? And this is, by the way, this is a big part of the design process. This DFM, design for manufacturing. We have to validate that this design, the design we are proposing and the customer is considering, this design has to be as easy as possible to assemble, which means it doesn't incur a lot of labor cost when we calculate the manufacturing cost of the product. If it can be automated, if the assembly can be automated, that would be fine. But also remember the quantity. Small quantities production means automating the assembly process will be very heavily affecting the unit cost. While if your product is expected to be vastly manufactured in huge quantities, so automating the assembly process or part of the product, which are considered half assembled products, that would be a very good idea. So the investment in the beginning is a bit high, on the high side, but as you go through the production process, this investment starts to pay off once you start getting large amounts of your product, and this also relieves the production line from any congestion points in the middle. So this is part of the production from the production design itself, this production design process. Okay, now this is just a simple overview at what we usually go through every day during the product development process. For us, we usually get a lot of requirements, and in so many various fields. We have a new guest in here. Hello, and great to have you in here. If you have any questions or comments, please don't hesitate to send us an email or drop us a line through this live chat, or you just can contact us through the online contact form on our website, and we will be with you shortly. So back to the design process. Once the design is done, the next step is to, of course, after design analysis, we go into prototyping. And in TOPWELL, in here, we have many various ways to prototype a product. So the obvious choice will be just 3D print or CNC the enclosure. PCBs, we would start with what they call duct tape prototype, or proof of concept actually, which is the very early prototype, which confirms that the approach we are taking in order to execute what the customer wants, this approach is working, and how effective is it if there are any unaddressed factors that we need to consider during the development process. And then once the proof of concept confirms that the customers or ours, can be both, Sometimes the customer would just come up with a request. I need a product that does so and so when so and so happens. That's all. That's all what we receive. And then by driving the conversation with the customer until we get him to express or to formalize what he expects or envisions or wants or needs the product to act, to perform, to behave. This way we can translate his verbal, descriptive requirements into technical specifications, and that's a very, very important step to go through, and we have to give it as much as needed of a time, because by the end of the day, most of the time the customer is not a technical guy, and our job is to understand what he wants, evaluate what he wants, realize what he wants, it's not envision. The correct word would be to anticipate what exactly going to happen through the development process in a very early stage, any major issues, any major challenges, and all of these has to be put on the table while discussing with the customer. Let him know that what he wants will lead to A, B, and C. A and B are already proven. C, while C needs a bit of an experimentation, investigation, re-evaluating. It depends. But by the end of the day, once we reach a working proof of concept, by that time we should have a very clear expectation on how do we think the product should be manufactured, how do we think the product should look like, should feel like, should behave. And then once all these items are listed down in the standard forms, a lot of ambiguity would already have been set aside, and then the path forward would be much more clear than what was in the customer's mind when he approached us. Driving the development, driving the process itself in the right direction is an art, and you only can accumulate this experience if you do know how it would happen, what would happen, what to expect, how to maneuver when the unexpected happens. Because by the end of the day, if you are making a product which already exists, this is not development. Developing something is that you create something from zero, from scratch. It didn't exist before you take place, you take charge of it. And by the way, this is one of the most enjoyable aspects of the development work that we do in TOPWELL. Actually, I have some engineers who really perform the best when being challenged by some true engineering challenges. Let it be manufacturing, let it be design, let it be concept, let it be solving, let it be problem solving. So, by the end of the day, if we get to the point where we do have a proof of concept which performs as the customer expected to be, perfect. we can move to the second step or the second phase. The second step or the second phase, as I've mentioned a few minutes ago, it's either mechanical, electronic, software, app development, server development, packaging development, and so on and so on, and of course mold making. But I will dive a bit deeper into the part which I'm responsible for, which is the electronic development. Of course, currently every single thing wants to be connected to something else, most probably connected to either to a server or connected to a mobile phone, which is connected to a server by itself. So there is some sort of connectivity. Some devices, or in some circumstances, some cases, some places, doesn't have the required coverage in order to allow a device to get connected. So, of course, in that case, there are other ways to get a device connected. But with the current, maybe it's euphoria, with the current trend, which is the AI, we as TOPWELL started to add the edge AI capability to our designs, which means some AI inferences would be running locally inside our device or our design without the need of an online connection to somewhere, either to a mobile phone or to a server. And of course, since we are talking AI, so of course the obvious and clear and mostly famous aspect of this is the machine learning, which means collecting as much data as the problem while we are training the model prior to deploying this model in the field after being trained. This also requires FOTA, which is firmware over the air update. This ability has to be in there either for updating the firmware or updating the model, or of course updating both. So all these design decisions has to be made during the process itself. And currently the machine learning part is becoming a separate approach than the firmware development. So the firmware development part is where the CPU controls the peripherals, controls the building blocks, different blocks of the system, and interact with the outer world, while there is a separate part of this, which is the machine learning or the inference running on board locally. This means when all these factors interact while the product is working, if we look at it from a design standpoint, different teams has to be preparing and working together in order to guarantee that the final functionality of the product is being maintained. I can see a new friend joining us. It's great to have you in here. Please, if you have any questions or comments, either drop us a line in here or please send us an email, and one of our team will be with you shortly. Thank you. Okay, back to the development process. So, as I was mentioning, adding the AI and machine learning to our products, of course, this is a new trend, and this opens a lot of applications that would have been almost impossible to implement using the normal and usual standard programming philosophy or theme. This is now, if we dive deeper into the PCBs, so board designs are becoming much more complicated every day, the board is smaller, is becoming smaller and smaller, the components are smaller and smaller, which means they are much harder to solder and prototype manually. The available area inside a device is becoming smaller because the device itself is shrinking down. Increasing the functionality and features of each product means more components inside, more complicated interconnections between the components, which means much more complicated PCB structure, board structure, which means with a limited size that we are expanding vertically. Expanding vertically means what? Means when you are designing or laying out a PCB, when this started, 40, 50 years ago, maybe something like this, we were talking about single and double layers, which means the board has only one layer of traces on the top and one layer of traces on the bottom, if it has, and that's all. But once the number of layers increases, the board routing and that becomes a true design challenge. Why? Because you are almost routing the board in 3D. This is 3D routing. When we talk about 12, 14, 16, 20, 25, 24, something like this, different layers. So traces are moving through the layers in 3D, not only in 2D where you are talking only X and Y, horizontal and vertical, and that's all. No. And this adds a lot of complexity to the design itself. Why? Because while you are, it's not just connecting points together. There are many aspects to be considered while laying out a PCB. There are signal integrity aspects, there are power integrity aspects, there are component distribution aspects, there are thermal aspects, there are let's say signal integrity or signal quality aspects. If you have an audio signal, so noises and noise prevention, you have EMI requirements. Most of the time you have also safety requirements, which means the ESD, because human beings are interacting with these devices and we are charged. We are usually charged all the time. We cannot discharge into a device where you just touch the USB socket and zap your board and render it unusable. All these factors are being taken care of during the design process, and the smaller the product is, the harder the task, the harder the job, the more complex it is. The point here is that we have to deliver what we have promised the customer, and we have to deliver it properly, which means once the design becomes functionally approved, it also means that this design has to pass EMI tests and has to pass ESD tests and has to pass any required sort of certification that we have already agreed with the customer upon. So sometimes a customer would say, oh, I just need a CE. Of course, okay. Others would require CE and FCC, TUV, or let's say UKCA, or any other one of the standard certification. So this has to be planned, this has to be pre-planned during the design process itself. Another point also, what we have seen since what we have started to see since the beginning of COVID-19, where the supply chain crisis caused a lot of semiconductors components not to exist. While things are much better right now, but there are still some parts which are usually out of stock, or they have tremendous lead time figures when we are talking about 70 weeks, okay, of waiting time. So with all these aspects in place, choosing components also is the challenge. Because if you are, as a designer, if you are choosing what components to use on the board, it's a very good approach to assign alternatives. So as the design process takes between a few weeks to a few months, most probably it's almost never a few weeks unless it's a very simple device. So a few months. So when the situation changes and the main component you have chosen becomes either hard to find or out of stock, I will not mention end of life, because that would be a design failure, technical foul. You shall double check the availability of the main components that you choose to build the product around. Otherwise, this is a recipe for failure. Choosing an MCU, CPU, choosing the memories, choosing the displays, choosing the main items, the main components of a design has to be done very carefully. Even if you choose candidate MCUs or candidate CPUs, number one, they must be pin-to-pin compatible with the original or the first choice, or your PCB has to be equipped to receive any of the possibly procured MCU. Otherwise, do not recommend a second MCU as an alternative. Number two, you cannot have or you cannot ask for any firmware change due to component change. So the firmware has to account for the possible alternative IC or alternative MCU which may be procured in case of the unavailability of the first chip. This is also part of the design. A design means you are planning how this thing needs to go and how should it be laid out, planned. So by the end of the day, the customer who have assigned us to design a product for him, he can go to manufacturing within the time that he expects to go without absence of components, things like that, and without extra cost, because the design decisions, these decisions made during the design process are the most, are the hardest on affecting the cost or the timeline when it comes to manufacturing and producing your design. So, as there are so many aspects, so many factors to be considered before endorsing a design to be approved, that it has to account for so many variables, so many situations. By the end of the day, once the design has been approved, prototyped, and the customer approved the golden sample, and by golden sample I do mean almost a replica of the final product. This is production grade enclosure, production grade PCBs, and production grade firmware. Of course, with the pressure, with the time pressure that we all go through the firmware is kept to the very end, and usually the customers use the time duration where the plastic molds are being manufactured and tested. They use this time duration to complete the firmware, and that's a technical foul. A rule of thumb from my old days: if you develop something in a month, you need to debug it in 6 months. That's the standard. Of course, everything is being squeezed down right now, but the right thing to do is your firmware will either be tested in the field for long enough time in order to endorse it as bug-free, and this bug-free is just it's just a consideration. It's not the truth. It's not the truth. Nothing is bug-free. Okay, it's good enough to be used in the field without disturbing the main functionality of the product, and that's what we call bug-free. But okay, so you have either inherited a stable product or a stable firmware where you are just making, let's say, minor changes, that you would be very lucky if you still have this mother site. If the product is a very new one, which means the process itself has to validate if the firmware is good, and of course the build of the product, if it's good enough to be introduced to the end customer. There is also another point where testing the product in the market is very different than testing the product before being released to the market. When you test before you release it, you can check for very, very special situations that maybe will happen once out of a million in the market. But if this is not severe problem, you can just, okay, you can accept the risk, because most of the time you are under huge time pressure. Going back to what we were saying in the beginning, designing a product is a science, both a science and an art. It requires continuous studying. It requires continuous following up to the market trends. It requires continuous learning process to either new technologies, new approaches, modifications on old technologies, emerging fields. And by the end of the day, when a customer receives his final product, while he is ready to deploy it to the market and start getting back his investment from both time and financial standpoints, this is what makes or what endorses a design to be a good one. Most of the time, I have seen so many brilliant ideas, but they were not being realized in a product. They haven't been very well planned, designed, manufactured. So by the end of the day, the customer or the owner, the concept owner or the solution owner himself did not reap what he kept seeding for a long time. This is why in TOPWELL, when we approach a design, we all love asking questions. And the more questions we ask, the more corners we refuse to cut, the more meticulous we are into envisioning, studying, investigating how the product is going to be used, manufactured, tested, validated, approved, certified. This gives us a huge opportunity. Number one, to fulfill the achievement of making something happen. Number two, allowing our customers to just come up with ideas or requirements or concepts or solutions. This is all what they need to do, and we cover the rest. That's the point. Third part is sometimes we get approached by customers who already have some designs in the market, but some of the components are already becoming obsolete. So he cannot manufacture his old product anymore. The point here is to come up with a change, a different solution that would give him the same performance while using some of the newly available components, rather than being stuck because one of the old major components of the board doesn't exist anymore. Maybe the company went down, the manufacturing company went down, maybe it's a technology change, maybe it's availability, which means the price tag of this component has become much more than what the product can withstand, the product cost range can withstand. By the end of the day, because we work in various fields of the market, our core benefit, our core strength is designing something. And by design, we mean designing all the aspects of the product. Either it's used, how the product is going to be used, how the product is going to interact with the user, size, weight, enclosure, certification, cost range. All these aspects are part of the design process. And as long as we are still in the market, as long as we keep improving our team, expanding our knowledge and our abilities, and utilizing the deep experience that we have collected and gathered over the years, 30 years is not short time. And most of our team members are at least 20 plus years experience in doing what they are doing. So in TOPWELL, our team is qualified to start your new product development for you, and with you together we can just receive your request or your idea and go through it together with you until we reach a working prototype and then move into the mass production stage. So by the end of the day, thank you guys for being with us today. It was a real pleasure to talk to you. Please, if you have any questions, if you have any comments, just drop us a line or send us an email, and we will be more than happy to start our discussions with you. Please also have a look at our website. We do work mainly in consumer electronics products, and our team is qualified to perform all sorts of activities which are related to the product development. In TOPWELL, we do manufacture all sorts of rigid PCBs, flexible PCBs, rigid flex, and also our team is widely qualified to give any required sorts of advices or suggestions to whatever technical challenges that the customer may be going through. Our long experience in this field has given us really good experience in reading the market, in interacting with new technologies, in just solving problems, design problems in a different way, and always finding a way out to let the customer requirement become true. So as long as there is any chance of collaboration between our team and the customer requirements, we would be more than happy to get into any discussions or interactions with the challenges that you are facing right now. Please send us whatever problems that you want to solve in your product. Send us whatever questions that you need us to help in answering, and regardless if the device has to be desktop or wall mount or wearable, if it's related to conventional computing or the new AI wave, if you have any requirements related to mechanical design, electronics design, PCB layout, microcomputer or microcontroller or CPU programming, which we call firmware, app development, server development, any items of these, please send us a message, drop us an email, and we will be more than happy to communicate with you, to start our technical discussions, to start investigating how can we, together with your team, get the problem solved, get the product out to your final customer. And also, if you currently have some defects in your product and you are looking for some innovative solutions, some out-of-the-box approaches, we are also more than happy to discuss this with your team. Just please contact us. We will just arrange for online meeting, and then we can discuss this with you and with your team. And by the end of the meeting, we are quite sure that we are going, or we will be able to suggest whatever the industry standards are already suggesting to solve your issues. If there is something which we are not very familiar with, that's also one of our strengths, that we are very, very good learners. So we would just dive deeper in order to get how to get this solved, relying on our experience and the varieties that we do have in our team. We will get this part done for you. We can suggest some out-of-the-box solutions for you, and then after that we can start to realize together how are we going to take this to the next step. Thank you guys for being with us. It was a short time. See you next time, and if you have any comments, just please drop us a line in here or send us an email. Thank you from Topwell, and see you next time. Bye bye.